Okay, first, bago tayo magsimula, message lang kay Lennox. Pasend na rin sa email ko para sigurado. Baka mabagal mag-upload kasi dahil mabagal talaga yung VLE natin eh. At saka, ang tawag dito, naka-Zoom pa at the same time. So, kung gusto mo i-send din sa email, pwede din. Okay, so, we're going to have our post discussion for lab experiment number 2. I don't know kung na-challenge kayo. I hope na-challenge kayo ng kaunti, especially dun sa discussion part. And yun din yung pag-uusapan natin ngayong araw. Okay, so first of all, ito yung didiscuss natin, yung power supply na circuit, what are the different, and then may question about kung ano yung different sources habang pinapanood ko yung video ninyo. So, and then may question din about may error sa figure, pero I think na-resolve naman yon nung isang group. And then pag-usapan natin yung answers dun sa to questions. Okay, so by the way, bago ko makalimutan, sandali. So, nakasabi dito sa VLE, nakasabi dito sa VLE na Danica, hindi pa submitted yung, naka-draft mode ka pa, so baka kailangan mo i-click yung submit button. Paki-check na lang. Ikaw din, Lennox, so tawag dito, naka-draft din. And Harvey. Okay, hindi, Harvey, meron tayong pinag-usapan regarding this. Everyone else, okay na yung submission. Okay, so yeah, sige Danica, mukhang dahil dun yun sa grouping eh. Yes. So itong experiment 2, first time kong ginamit yung grouping sa VLE. So hindi ko pa siya gamay. So ngayon naintindihan ko na yung problema at alam ko na kung paano siya gawin sa next time. So next time, hopefully hindi na kayo magkaroon ng problema sa pag upload ng inyong submissions. Okay? So, ang pag-uusapan natin ay yung power supply. So let's go directly to that. And I'll show yung familiar na power supply na circuit. Okay. So hopefully, well, nakita ko naman na ganyan din more or less yung itsura ng output ninyo, and then scope. So ganito. Okay, so just so you know, kung ano yung chinechekan ko. Oops. Kung ano yung chinechekan ko sa bawat circuit. Of course, chinecheck ko yung values na given. Okay. Next. Okay, so kailangan ko i-reload ulit yung aking circuit. Nakita ko na sa email, Lennox, yung submission. Thank you. Okay. Okay, so just so you know, ang chinechekan ko dito, of course, ay yung values na nilalagay ninyo dito. So this has to be nakalagay dito, dapat 12 times square root of 2. Okay, or of course, 17, yung iba sa inyo nilagay 17. Okay, and then 60 hertz, and then dito sa capacitor, dapat ito ay 1,000 microfarad, and then sa resistor ay 1 kilo ohm. And then, syempre, chinecheck ko din kung tama yung circuit. Pero of course, kung mali yung circuit, magiging mali din yung output ninyo. Oops. Sorry. Gawin natin itong 5 cycles. Okay, so ito yung in-expect nyo na magiging result, right? So itong time scale and then amplitude or voltage scale. So of course, ang makikita nyo rito ay yung ripple voltage. So pwede nyo i-zoom in yan. Okay, dito makikita nyo na yung ripple voltage. So merong time na kung saan magdi-discharge, mag-charge pa yung capacitor. Okay, and then after about mga 40 milliseconds, magiging constant na yung, 30 milliseconds, magiging constant na yung ano niya. Yung tawag dito, kanyang voltage or yung DC voltage. And pwede nyo makita actually yung ripple voltage dito by taking a look at by taking a look at yung amplitudes. Okay, sa dito. Okay, so if you're wondering kung talagang nag-experiment tayo, ganito din actually yung gagawin nyo in an actual experimental setting. Okay, kasi ang gagamitin nyo in that case na equipment ay tinatawag na oscilloscope. And sa oscilloscope, you can actually, you have these vertical bars to move around para malaman din kung ano yung amplitude niya. Okay, para sa mga advanced na oscilloscope na to. Pero yung mga lumang oscilloscope walang ganitong feature. Pero dun sa mga advanced oscilloscope, and we have one at least, pwede nyo makita yung, may mga vertical bars to move around at makita nyo kung ano yung values. So, for bar 1, it's tawag dito, or yung difference in voltage between bar 1 at saka bar 2. So, sa bar 1 is 15.655, sa bar 2 is 15.4. So, yung difference in voltage is 114. So yan yung itong delta Y, yan yung inyong ripple voltage. Okay? Okay, so and then so yan yung isang paraan para ma-measure yan. Of course, dito sa linya na to, kitang-kita nyo kung ano yung DC voltage. Ang DC voltage niyo is 15.6. Okay, so sa actual ganito din yung gagawin niyo na type of measurement. So you're going to zoom in dun sa ripples. Okay, titignan niyo yung upper at lower peaks ng ripple para makuha niyo yung ripple voltage. And then titignan niyo yung by eye or siguro taking the average between the two. So halimbawa ito, this is about 57. So 57 plus 15.541, mga around 15.6 something, di ba? So yun yung ilalagay nyo o yun yung magiging parang DC voltage niyo. Okay, so also you have to understand na sa oscilloscope, hindi nyo makikita itong nangyayari dito sa part na ito. Okay, sa initial time na nag-i-increase pa lang. Ang makikita niyo sa oscilloscope kaagad ay ito na, yung diretsong voltage na. So, kasi ang ginagawa sa oscilloscope, it doesn't start from zero. So, it continuously measures. So, nagme-measure na siya ng tuloy-tuloy. So, hindi nyo na nakikita yung initial na time. So, just one side comment. Nung nakikita ko sa iba sa inyo, nung pinapanood ko yung movie, hindi nyo ma-figure out kung paano, yung isa sa grupo hindi ma-figure out kung paano ibalik dun sa dati. Actually, all you have to do is unclick yung zoom. So, i-click nyo ganyan and then piliin nyo lang tong extend. So, if you click this, ang makikita nyo ay ang mag-zoom out nyo yung extends along the X and then pag ito, yung extends along the Y. So, pag kinik natin yan, nakita natin extends along the Y and then pag kinik natin to, extends along the X. Pero pwede nyo i-click itong button na ito para makuha yung extents ng X at saka ng Y. Or para bumalik siya dun sa original na image ninyo. Okay? So, yan yung measurements na gagawin nyo sa actual na experimental results. Okay, of course, ang iba pang measurement na gagawin nyo is when you change the resistance at saka resistors, which is yung isa sa mga items dun sa question number 4. Dun sa questions, okay, which is yung question number 4. So, ano yung effect essentially ng resistance at saka ng capacitance. Okay, so we'll take a look at that a little while, in a little while. For now, okay, ang gagawin natin ngayon is balikan natin yung theory. Okay, so ito ngayon yung theoretical treatment. Okay, so of course you can go back dun sa mga equations na alam niyo and do everything by hand, but you probably forgot na nag-send ako ng code na ganito. Okay, so dun sa VLE, oops, sorry, dali. Okay, so dun sa VLE, okay, dun sa power supply. So, and dito yung, of course, dito, andyan yung theory. And then, somewhere here sa baba, okay, ay nag-send ako ng code. Wala pala akong sinend. Okay. Akala ko meron akong sinend. Yep. Okay. Sige. My mistake. Anyway, i-share ko naman sa inyo itong lahat ng files na ito. So, lahat ng files na nakikita nyo dito sa anong tawag dito? Sa MATLAB drive, ay i-share ko mamaya sa inyo. Okay. After nung lesson. Okay. So, meron pala akong sinend nung week 5 ng MATLAB file. Okay. So, yun. So, yun, meron pala akong sinend sa inyo. So, actually, you didn't have to reproduce yung results. And that was a anong tawag dito, a MATLAB file. Ito ngayon, this is a live script. So, ginawa ko lang from a MATLAB script to a live script. So, binago ko siya ng konti. So, ito na yung makikita ninyo. Okay, so ito yung parameters na binabago. Of course, yung resistance. Oops, balik natin to sa 1,000 microfarad. Okay, and frequency is 60 Hertz, and then yung input voltage is 12 times square root of 2. Then if we plot that, so ito yung ating input voltage Okay, and you plot yung rectifier o rectification, action ng rectification. No, dahil sa 4 na diodes, ito yung magiging output. Okay, and also pag dali, i-run ko na lang to. Pag gusto niyo nang makita kung ano yung effect nung capacitor at saka nung resistor theoretically, makikita niyo yun dito. Okay. Now, when you run this, makikita nyo na may, anong tawag dito, merong exclamation mark doon. Ibig sabihin may error somewhere. And that is because yung error ay ito, out.theory. Saan natin kukunin yan? Well, actually, kukunin yan natin dito sa power supply. Okay, so we have to run ito. Kasi itong circuit na ito will generate a data file na tinawag ko na theory. Okay, so if you recall from the previous meeting, pwede tayo mag-generate ng data. Okay, so yung generation ng data, inassign ko sa file name na theory. So ngayon, pwede ko nang i-run itong part na ito at lalabas na yung theoretical result and pwede natin i-compare with the experimental result. Okay, so in general, in any type of graph, okay, yung theoretical result is always plotted against, anong tawag dito? Is always plotted as a line, and pag experiment, it's always plotted as a dot. Okay, so itong dots dito, yan yung experimental result which was generated from yung Simulink. And anong tawag dito? If kung itong line na ito na-generate dito sa MATLAB file. So if we zoom in dito, makikita natin, oops. So if we zoom in here, okay, makikita natin na yung experimental result doesn't really fit with the theoretical results. Okay? So, which is actually what happens oftentimes naman, di ba? When you're doing experiment and you plot the experimental result with the theory, hindi siya talaga nag-fit. Okay? Pero dito sa Simulink, ito, simulation na nga ito, hindi pa rin siya nag-fit. So, ano sa tingin nyo yung reason? Okay? Kung bakit hindi sila nag-fit? Meron kayong idea? Or suggestions kung paano may improve? Oops. Walang suggestions? Walang ano? Kahit anong idea? Okay, so anong nakikita nyo dito? Ang nakikita nyo dito is a difference. Yung blue curve, of course, yan yung theoretical, and yung dotted, tawag dito, results. Yung circles, ayan yung experimental. Okay, so well, tawagin na natin siya experimental din. Okay? And pag nakakita kayo ng ganito, okay, ang isang una nyong iisipin, of course, is remember that the y-axis is a voltage drop. So ang isang iisipin nyo, merong difference in voltage between the experimental result and the theoretical result. Okay? In the same way, na merong difference in voltage between itong input, okay, na signal at saka yung kulay red, yung kulay pulang curve. Yan yung output from the rectifier, okay, without the capacitor. Okay, so bakit may difference between the black and the red curve? Kasi nga, may voltage drop. Ano yung voltage drop na yun? Ang voltage drop na yun is yung voltage drop across the diode. Okay? Now, since dalawang diodes yung dinadaanan, okay, ibig sabihin, the difference in voltage between this amplitude of the peak voltage ng black at saka nung red should be twice the diode voltage. So kung titignan nyo, this is about 17 and this is about 15.8. Okay? So that's about 1.2 volts. Okay? Okay, sige. I-discuss na rin natin ito para hindi na natin balikan mamaya. Bakit 1.2? Bakit hindi 1.4? Nakaka-affect po ba yung internal resistance ng diode at capacitor? Actually, that's the reason kung bakit may difference between this theoretical at saka experimental curve. Okay, so that's, yes, Vince, that's very good that you thought about it. Okay, pero balikan natin yung discussion na yun, pero dito muna tayo mag-focus sa diode. So bakit hindi 1.4 yung difference, kundi 1.2? Okay, and nakita ko nga dun sa ibang mga reports na na-checkan ko na ina-assume nyo actually na 0.7 volt yung diode, yung drop dun sa diode voltage. Okay, now let's go back dun sa power supply. Okay, dito, ito yung diode ninyo. Okay, and if you double-click yung diode na yan para makita yung block parameter, it's essentially the same as you measuring the diode voltage, okay, anong tawag dito? In an actual experiment. Okay? So, kung titignan nyo rito, it's 0.6. Yan yung default value. Okay? Pwede nyo i-verify yan later after ng meeting natin. Balikan nyo itong code niyo, makikita nyo na 0.6 talaga yung nakalagay. So, hindi ko binago ito. This is the default value. Okay, so this is 0.6. So for most of you, yan na yung isang source of error. Okay? Yung calculations ninyo, most probably you assume na yung diode voltage is 0.7. Okay, hindi 0.6. Okay, so you really have to check first kung ano yung, or measure kung ano yung voltage across each of the diodes. Okay, so para lang ma-verify nyo na the diode or kung gaano kalaki yung extent ng error na kinocontribute ng diode voltage. Okay? So yun yung isang source of error. Okay, now that we know na in this case, itong blue theoretical at saka itong dots experimental ay hindi dahil sa difference in diode voltage, it could be from another source. So if it's not from the diode, ano pa ba yung pwedeng mag-drop? So capacitor, pwede siya mag-contribute sa additional drop in voltage, and resistor, pwede siya mag-contribute sa additional drop in voltage. Okay, now, again, if you look at this circuit, okay, and you double-click itong capacitor, okay, you'll see na meron siyang series resistance na 1 times 10 to the minus 6 ohms. Okay, so, tingin nyo, magko-contribute ba ito? I mean, 1 times 10 to the minus 6, is this really significant kumpara dun sa anong tawag dito? Resistor? Okay? Or series siya dito, no? So, actually, parallel siya. So, this is, kung titignan nyo, itong 1 times 10 to the minus 6 na to, naka-series siya dito sa capacitance, pero naka-parallel siya dito. So, you have 1 over 1,000 here. This is 1 over 1 times 10 to the minus 6. Diba? Tapos, anong tawag dito? So, yung equation is 1 over, ano tayo mag-annotate dito? Natin kung mag-work. So, equation is 1 over 1 times 10 to the minus 6 plus 1 over 1,000. Okay, magko-contribute ba siya? So this is, ito actually, this will be, okay, this will become 1e to the minus 3. At ito naman ay magiging 1e to the 6. So pag in-add mo yung dalawa, so this is 1e to the 6, or yung effective na resistance nito is 1e or 1e to the minus 6 ohms. Okay? So anong ibig sabihin nun? Meron kayong effective na resistance dito na 1e to the minus 6. Multiply that by the current, it's a very small voltage. So walang effect itong series resistance na yan. Okay? Dun sa voltage. You can verify that. Okay, so clear lang natin ito sandali. Then close. You can actually verify that kasi if you just, for example, change this to 100, okay, apply, okay, and then we run this again. Okay, and i-run din natin ito. Okay, so magkakaroon kayo ng multiple na blue dots dito dahil naka-hold on yung graph. Okay, so and if we zoom in, oops. Okay, so if we zoom in, ito yung blue dots. Kung makikita nyo, doble-doble na yung circle, di ba? And that's because naka-hold on nga yung graph, and ibig sabihin nag-overlap lang yung result from the series resistance na 1 times 10 to the minus 6 ohms at saka 100 times 10 to the minus 6 ohms. So there's really no difference, or there's no effect due to the series resistance. Okay? Yeah. So ano pa? So kung hindi dahil sa series resistance, ano pa yung pwedeng panggalingan? Okay? So makikita nyo, of course, dito yung resistance, wala naman tayo ibang pwede dagdag dyan. I mean, it doesn't make sense na may internal resistance yung ano. And then of course, meron siyang tolerance value, but yung tolerance value is about what? 5%. So ang contribution lang dito is 50 ohms, di ba? So 50 ohms is not that much. So ano pa yung hindi natin natitignan? Well, yung third na element dito is of course yung diode. Okay, now, kung titignan ninyo, yung diode has an on resistance of about 0.3 ohms. Is that significant? Okay. Significant ba yan? Or hindi? Well, let's find out. Okay. So, it could be due to the resistance of the diode. Kasi ano pa ba? Wala na ibang natitira. Right? Okay, so pwede natin palitan ito to 30 para lang ano natin yung effect. Okay. And okay, and then we run it. Okay, so i-run din natin ulit ito. Okay, and immediately kitang-kita nyo na merong effect yung diode resistance. So if we zoom in here, okay, so ito yung kanina, itong nasa ibabaw. Okay, yan yung pag 0.3 yung diode resistance. So itong part na ito. Okay, yan yung 0.3 na diode resistance. And then itong part na ito yung anong tawag dito, or 30 ohm na diode resistance. So by increasing yung diode resistance, actually nag-increase yung difference between these two. So ito at saka yan, diba? Nag-increase yung difference, which means na nag-increase yung, or merong mas lumaki yung voltage drop across the diode. Okay? So that means na yung diode resistance is the culprit for the difference between the theoretical and the experimental result. And we can actually reconcile that, okay, by changing the diode voltage. Okay, so nilagay natin dito 30, no? So if we change everything by 0.3, lahat ng diode voltages, lahat ng diode resistances. So from 0.03, gawin natin from 0.3, gawin natin 0.03. Okay. So apply. Okay. Okay, and actually, gusto kong i-run itong buong code muna para matanggal na itong mga ibang dots dyan. Kaya mas maging malinis yung result. Okay, and going back. So, i-run natin ito ngayon. Okay, and then run this part. And even without zooming in, kitang-kita nyo na yung effect ng diode resistance, internal resistance ng diode. Okay? So, anong pinakita natin dito? Well, of course, pinakita natin kung paano, kung paano natin, kung ano yung process, ano yung thought process para i-analyze or i-troubleshoot yung circuit natin. Okay? Ang naging process natin is this. Nung nakita natin na mayroong difference between the theoretical at saka experimental, nakita natin na yung difference is along the y-axis. Ang y-axis natin ay yung voltage. So ibig sabihin there's a voltage drop between the theoretical and the experimental. And in fact, yung experimental is lower than the theoretical, which means na talagang nag-drop yung voltage somewhere. So may malaking contribution sa voltage drop somewhere. So meron tayong tatlong circuit elements. Yung resistor, capacitor, at saka yung, anong tawag dito? Yung diode. Nakita natin, of course, yung resistor has a tolerance of about 5%. And yung tolerance na will just give you about, anong tawag dito? 25 ohms. Okay? So, 25 ohms kumpara sa 100, 50 ohms kumpara sa 100 is very negligible. Okay? What about yung series capacitance? Well, yung series capacitance, it's even smaller kasi it's 1 times 10 to the minus 6. Kahit nga i-multiply mo siya by 100 times, hindi pa rin siya nagkakaroon ng effect. So finally, we took a look at the internal resistance of the diode. Okay, and when we saw that the internal resistance was significant, it's about 0.3 ohms. Okay, and by simply decreasing yung magnitude niya by 1 order, nakita natin na nag-match na yung experimental with the theory, which proves yung hypothesis na yung diode yung culprit dito sa case na ito. Okay, so yun yung thought process when you are analyzing a circuit. Okay, so when you begin to ask why, kailangan yung tawag dito, intindihin kung ano yung, tignan kung ano yung difference, and then from based on what you've learned from lecture, ano yung source ng difference na yan. Okay? So this is not a guessing game. Okay? This is always based on what you've learned from theoretical from theoretical results. Okay? So yan yung para dyan sa anong tawag dito, para dyan sa circuit na yan. Okay. So now that we've analyzed yung circuit natin, okay, so ngayon puntahan na natin yung answers to or yung questions. Okay, so let me just go dun sa mga questions dahil hindi ko kabisado. Okay, at this point, meron ba kayong tanong? Wala, sige. I hope na naintindihan niyo yung lesson. or yung diniscuss natin. So, okay, typically you choose a capacitor in the order of 1,000 microfarad and resistor below 1 kilo ohm. Okay, why is this? Okay, well, the reason for that is time constant. Okay, you want a time constant that is faster than yung tawag dito, yung frequency of oscillation ng circuit. And in this case, yung frequency ng oscillation ng circuit is dictated by itong power source ninyo, yung power supply. So yung power supply is 60 Hertz and you want the time constant to be faster than 1 over 60 Hertz. Okay? 1 over 60 is 16.7 milliseconds. So you want the time constant to be at least 10 times tawag dito, the period, okay, which is 16.7. So you want it at least to be 167 milliseconds. Now, kung ilalagay nyo sa 1 second, which is what we did here, kasi 1,000 ohms at saka 1,000 microfarad, that's about 1 second the time constant. Okay, that's a fairly good, 1,000 kilo, 1 kilo ohm times, that's 1 millisecond pala, sorry. So 1 millisecond is much, much faster kumpara sa 16.7 milliseconds. Okay? So, so nagkamali pala ang computation kasi we want it to be faster. So 16.7 milliseconds yung time constant. So you want it to be, if you multiply the speed by 10, so that's 1.67 milliseconds. So 1 millisecond is fine. Okay, na time. Okay, so that's the reason why you are choosing capacitor values that are actually high, okay, or well, not high, but have a time constant of 1, at least 10 times faster than yung frequency of oscillation ng circuit nila. Okay, number 2. Compare between the output of your simple circuit in experiment 1, okay, and the output of the bridge rectifier when there is no capacitor. That's actually what we already did here. Okay, so in this case, pinakita na natin yung difference in output dun sa original, which is yung black curve. Okay, yung red, which is yung output from the tawag dito, bridge rectifier. Ang tawag dito. And then next ay yung blue curve pag nagdagdag na tayo ng capacitor. Okay, so kitang-kita na natin yung differences dito sa result na ito or dito sa graph na ito. Okay. Okay, so compare these 3 simulated results with theory you learned in the lecture. Okay, you must show the figures of the 3 outputs and the complete theoretical calculations. Okay, of course, if you do it like kung anong ginawa dito na yung MATLAB yung ginamit, it's fine kasi makikita naman tawag dito. Ma-generate nyo naman yung graph tawag dito base sa tamang MATLAB na di ba? MATLAB na code. So if you just, kahit na ipakita nyo lang sa akin tong graph na to, or of course, if you want to do it by hand, that would be also fine. Okay, and then in your report, just indicate kung ano yung mga equations na ginamit ninyo. You don't have to show yung full calculations. Okay, so ano yung mga differences? So pinakita na natin isang discrepancy. Ang isang discrepancy ay at least dun sa ilang reports na na-checkan ko na, yung isang discrepancy ay yung difference between the rectified output voltage experimentally at saka rectified output voltage theoretically. Okay? And yung error dun sa mga na-checkan ko na report ay dahil sa inassume ninyo na 0.7 volts yung diode voltage. Okay? So yun yung isang discrepancy. And then dito, tinignan din natin yung discrepancy between the experimental result, yung blue circles, at saka yung theoretical result, yung blue lines. And nakita natin na yung discrepancy is due to the diode, internal resistance of the diode. Okay, and we don't have to do anything else here dahil nakita naman natin na nagmamatch na yung experiment with the result. Okay, so kung meron kayong hypothesis, okay, at tinry out nyo yung hypothesis in exactly the same way as we did, okay, kasi ang hypothesis natin is, okay, may voltage drop siguro sa diode, and bumalik tayo sa Simulink, pinalitan natin yung series resistance. Okay, yun yung culprit. Nakita natin na nag-match na ngayon yung theory with experiment. So, na-verify ngayon yung hypothesis natin. Okay, so now that there's no discrepancy, there's actually nothing left more to explain. Okay, so yun yung hinahanap ko at hanapin ko dun sa mga reports ninyo. How you tried to explain yung discrepancies. If you just say na it's due to rounding off error or anong tawag dito, due to the internal resistance of the diode, okay? Lahat nun hypothesis, but without any type of verification, then tawag dito, it's essentially you did nothing, diba? You did not follow up on your hypothesis. And nakita nyo naman dito na it's easy to follow up on the hypothesis. When you do experiments naman, kung makita nyo na meron kayong discrepancy between the experimental result and the theoretical result, and meron kayong hypothesis about yung difference between the experimental at saka theoretical, then you follow it up with a succeeding experiment. You modify your experimental results, okay? And according dun sa hypothesis ninyo, okay? So that's actually what you do when you do experiments, okay? Sa undergrad, sa lower physics na courses, hopefully yun dapat yung embed sa inyo. But this is actually an advanced physics course. So this is an upper class physics course na may experiment or virtual experiment. And in this case, you have to follow up on your hypothesis. Hindi na enough na meron kayong hypothesis lang. You really have to follow up dun sa hypothesis na yan. Now, I'm telling you this not just because upper class na kayo, okay? But and also not because magti-thesis na kayo, kasi when you do your thesis at mag-experiment kayo, this is exactly what you're going to do. Okay? Mag-experiment kayo, meron kayong error, i-figure out nyo kung ano yung error na yun, and if you can do a succeeding experiment to minimize yung error, okay? Modify the experiment to minimize the error, you have to do that. And again, hindi ko lang sinasabi para lang dahil na magti-thesis na kayo, but if you want to have a career later on as a researcher, this is what a researcher does. Okay? Experiment, compare with theory, okay? May hypothesis dahil sa error, okay? You tawag dito, you modify the experiment and then you do the experiment again, okay, with the modifications and try to see if your hypothesis works. Okay? Ganun ang process ng tawag dito, experimentation, regardless kung nag-undergrad physics kayo or kung gumagawa kayo ng research. Okay? So let's move on to the final question. Okay. Ko lang yung... Okay, so dun sa final question, okay, ang final question is about the difference between kung ano yung effect ng resistance. Okay, so itong nasa gitna, this is the graph for the resistance when our for the resistance na 1 kilo ohm at saka yung capacitance na 1,000 microfarad. Okay? Dito naman sa kaliwa, this is for a resistance of 100 ohms, pero same capacitance. Dito sa baba, same resistance, okay, pero this is 100 microfarad. Okay, and dito naman sa upper right, this is 10 kilo ohms, so tumaas dito yung resistance. And dito naman ay tinaasan ko yung capacitance. Ginawa kong 10 millifarad, okay, or 10,000 microfarad. Okay, so 10 times higher than this. Okay, so ano ang makikita nating effect dito? Of course, ito nakita na natin yung result na to kanina, no? So, ito na natin yung color ng konti. Nakita na natin yung result na ito kanina. Okay, at alam natin na yung difference between the theoretical at saka yung experimental ay dahil dun sa diode voltage or diode internal resistance. Okay, now if we take a look at, or if we decrease the resistance by tawag dito, 1 order of magnitude, okay, makikita natin na yung ripple voltage, okay, is actually larger kumbaga sa ripple voltage dito. Okay? And kung titignan naman natin, kung i-increase naman natin yung resistance, yung ripple voltage dito becomes much smaller kumpara sa ripple voltage dito. Okay? And that's just because of the time constants. Okay? So that means that here, okay, yung charging or yung discharging na part, okay, dito, yung discharging na part, okay, is slower, okay, kumpara sa discharging dito at saka yung discharging dito. Okay? So this is a time constant. Okay, sorry. Baliktad. Yung ulitin natin. Clear everything. So yung discharging dito is actually faster kumpara dito at saka kumpara dito. Okay, yun yung ibig sabihin ng time constant. Ang time constant dito is 10 seconds, so which means na matagal siyang mag-discharge. Okay, ito naman, 0.1 seconds, which means mabagal siya mag-discharge. And dahil mabagal siya mag-discharge, mas malaki ngayon yung voltage difference. On the other hand, dito, okay, dahil mabilis siya mag-discharge, mas malaki yung voltage difference. Dahil dito, mabagal yung discharging niya, yung voltage difference is extremely small. So yung effect lang when you change the resistance is to change yung time constant, which translates to changing the discharging time of the tawag dito, series capacitor and resistor or parallel capacitor and resistor network. Okay? Okay, now ano naman yung effect ng capacitor? Now, if you take a look here, ito, okay, so makita nyo rin na meron ding mas mabagal na discharging, mas mabilis na discharging voltage. Okay, and that's also because of the time, because it's actually, they have the same time constant dito. Okay, so kung titignan nyo, they almost have the same results. Okay, almost. Kasi kung titignan nyo dito, yung dots o yung circles ay aligned na with the or experimental is the same as the theoretical. Kung titignan nyo dito, yung experimental ay meron pang konting voltage drop with the ang tawag dito, with the theoretical result. Okay, so first of all, bakit ganon? Bakit dito nagmamatch na yung theory at saka experiment, pero dito hindi nagmamatch yung theory and experiment? Okay, dito ang alam nating rason na difference ay dahil dun sa diode resistance, right? Pero dito hindi na to pwedeng diode resistance kasi the only thing we changed here ay yung capacitor value. Okay, from 1,000 microfarad to 100 microfarad. farad. Okay? Now, anong ibig sabihin nito? Okay, remember that this is a parallel capacitor at saka resistor network. So, ibig sabihin, okay, when you do the calculation, ang una nyo munang ginagawa pag parallel, kinukuha nyo yung inverse, di ba? So, if you change the capacitor from a higher value, 1,000 microfarad, to a lower value, okay, which is 100 microfarad, you're changing, okay, the inductive capacitance, or you're increasing the inductive capacitive reactance. Sorry. So you're increasing the capacitive reactance. So you're increasing, well, in some sense, yung resistance. So increasing that that resistance or capacitive reactance adds to or subtracts yung voltage, okay, from the anong tawag dito? From the experiment. Okay. Sa parallel circuit, hindi nyo actually tinitignan yung capacitive reactance, but you're taking a look at the capacitive susceptance. So in this case, yung capacitive susceptance ay bababa. So if you have a capacitor that is parallel with a resistor, so ibig sabihin bumaba yung conductance dito. Okay, bumaba yung conductance dito. So dito tumaas. Okay, so you're actually increasing yung voltage dito dahil mas marami ka ng current dumadaan dito, you're increasing yung voltage dito. Kaya nag-increase yung voltage dito. Okay, so that's what happened. That's the reason for the difference between that's the reason why the difference between the experimental and the theoretical curve decreased when you change the capacitance here compared to when you change the resistance here. Okay, by the same order of magnitude. Okay, now let's go to the most intriguing result. Dito, ang ginawa natin dito is we actually increased the capacitance by 10 times from 1,000 to 10,000 microfarad. In fact, yung iba nga sa inyo, especially yung unang gumawa ng experiment, bago ko nag-introduce ng correction, ginamit nyo is 1,000 millifarad, which is essentially 1 farad. Diba? So, at ang nakita nyo yung result is a very, very slow na tawag dito, increase in current. Okay? So, anong effect ngayon nung capacitance na ito? Okay, by increasing the capacitance, anong nangyari dito? Well, if you increase the capacitance, yung XC, syempre bababa, which translates to a BC, yung conductance na tataas. So in this case, dito ngayon, mas mataas na yung yung current. At dito, bumaba yung current. At dahil mas mataas yung current dito, at dahil yung current dito ay hindi naman instantaneous, okay, na magi-increase, it has to, tawag dito, charge up slowly. So ang nangyayari dito, meron kang charging time which has increased by a factor of 10. Okay? Yung charging time mo nag-increase by a factor of 10. So imbis na sinusunod niya tong blue curve, okay, ito na yung sinusunod niya na result. Okay? So yung charging time increased by a factor of 10. So you can actually verify that kasi dito, if you, okay, so hindi maganda yung pagka-drawing ko ng linya. No? So if you extend this, itong peak na ito will be about 15.6 volts. So 63% nun is about 9. So that's somewhere here. And if you extend that downward, that's about 16.7 milliseconds. Okay, which is about 10 times faster kumpara dito sa oscillation na ito. Okay, ano bang oscillation na ito? Okay, remember this is 1 point. Okay, so ang isang period nito is 16.7 nga, di ba? So So ibig sabihin kalahati nito is 8.8, 8.6, or 8.8, 8.9. And then somewhere here, okay, so ito yung charging na tinitignan natin. Ano? So ito, nag-charge siya. So this is 15 and somewhere here, yung ano niya. So this is, kung project mo yan, that's about, well, that's about 10 times kumpara dito. Okay, yan. Yung value ng time niya is about 10 times kumpara dito. Okay, so yun yung reason, okay, kung bakit ganito yung nangyayari. Okay? So, iba yung effect ng resistance at iba yung effect ng capacitance. Okay, dun sa circuit. Yung resistance only changes the voltage difference. But yung capacitance not just changes the voltage difference, but also changes the anong tawag dito? Charging time of the capacitor. Okay? So yun yung mga hanapin kong sagot when I check your tawag dito, submissions. Okay? Any questions? Any questions? Okay, so I hope na nagme-make sense yun. Okay, so okay, moving on. Okay, now, ito yung discuss natin. Maraming late ang nag-submit. Bakit kayo late nag-submit? Ano yung mga reasons? So, iisa-isahin ko ba kayo or magta-type in na lang kayo ng ano, ng reasons ninyo sa chat box? Sige, bigyan ko kayo ng 1 minute para ano, magsabi kung ano yung reason kung ba't na late kayo sa pag-submit. Okay, so isa-isahin ko na lang kayo. Yes, that's right. Na-late kayo ng ilang minutes. Okay, sandali. Okay. Okay lang yung na-late ng ilang minutes. Okay, it could be some minor problem. Nung chinek ko upon submitting the paper, nag-adjust yung margin at naging 4 pages. Yeah, okay, sige, so formatting lang yan. Okay, group 1, ba't kayo na late mag-submit? Group 1 ay si na Harleen at saka si Franz. Kahit i-type nyo na lang, send na lang kayo ng private message sa akin. And alam nyo kung gaano kayo katagal na late. Group 2, Group 2 okay lang. Group 3, okay, Group 4, JD. At saka Crisel. Dito ba kayo? Wala sila JD at saka si Crisel. Okay. And then yung iba, yung individual nag-submit. Yeah, it's fine. Oo. Okay lang. Okay, wala kayong reason na binibigay na late? Other than talagang sige. Sige, maghihintay ako. Pero huwag masyadong matagal. Okay, so yung ibang nag-submit ng late, wala rin dito. Okay, anyway. Now, hindi ko naman pinagdidiinan na tawag dito, kailangan nyo talagang mag-submit on time. Of course, it's should be the right thing to do. But of course, kung may mga circumstances na that would prevent you to okay na yan. So yes, nabasa ko Lennox, just so you know, nabasa ko na yung sinabi mo. So Danica. Ay, hindi. Sorry. Danica, hindi. Tama. Hindi considered yun na late. Okay. Now, so alam ko naman na medyo mahirap ngayon sa sitwasyon natin. Pero if you have reasons that are valid naman, it's fine. But if you don't have reasons other than yung normal reasons ninyo pag ordinary times na okay, last minute nyo na gagawin and so on and so forth. So, of course, it's always not a good reason na mag-submit kayo ng late dahil late na kayo nag-start. Okay, and for that, maganda na ang tawag dito. Ma-remind kayo constantly about this. Okay, na we should respect each other's times. Okay? So, nung tinanong ko naman kayo about yung mga deadlines, wala namang nag-complain. So, I was expecting na magsasubmit kayo on time. And in fact, kanina, for whatever reason, okay, dahil dati hindi naman, kanina, 3 lang yung dumating ng 4:30. Okay? The rest dumating after 4:30, 10 minutes later. So, ano yung rason? Remember that some of your classmates don't have, anong tawag dito, or are struggling with their internet access. So, parang limited yung time nila. Okay? So, we have, lalo na ngayon, we have to be considerate with each other's time. Okay? So, in this case, ano ang gagawin nating sanctions? Okay? Anong mapag-agrihan nating sanctions? Of course, ang nakikita kong sanction is deduction sa points. Okay? So, ano sa tingin nyo doon? What do you think about it? So, pag na-late without a valid reason, magbibigay ako ng point deduction. Just to be fair with the others na they're submitting on time. Okay ba 'yon? Let's say tawag dito, 1 point deduction for being late. Okay, now 1 point may not be enough, pero if this kung gagawin niyo pa to sa next 4 experiments, that's already 4 points deduction. Yeah, yung mga ganyang problema. So kung yung wala kayong kuryente, okay lang 'yan. Hindi ko 'yan tawag dito. Hindi ko 'yan kaya ka na late. Okay. Sige, walang issue sa akin 'yan. Okay, basta lang mayroon naman kayong valid reason. Pero kasi ngayon tinatanong ko kayo kung ano yung reason ninyo kung bakit kayo na late mag-submit at kung bakit kayo late dumating, 'di ba? If you don't present to me a valid reason, then I'm going to impose yung deduction, so yung sanctions, yung deduction na yan na 1 point. Okay? I hope you find it fair for everybody else. Okay? Okay, so if you agree or if you think that it's fair, hindi. 1 minute 55 seconds late. Sobra naman siguro ako kung magde-deduct pa ako ng 1 point para lang doon. Pero yung iba kasi 9 hours, 10 hours, 'di ba? So I mean that's really not uh, kung of course kung nawala ng kuryente, wala akong magagawa doon. Kailangan kong intindihin 'yon. Okay? So ganun. So just give a thumbs up kung nag-agree kayong lahat dun sa deduction ng points for being late without any valid reason. Okay, so 1 point. Okay? Okay, so nakakita ako ng maraming thumbs up dito. Okay, good. Next. Okay, so sinabi ko na to. I think I know how to use yung VLE groups. So I hope na hindi na kayo magkakaproblema sa sa tawag dito sa submission, future submissions niyo. And kaya kayo nagkaroon ng problema ngayon sa mga submissions, especially yung mga individual na nag-submit, ay dahil sa mali ko yun, error ko yun dahil hindi ko naintindihan yung VLE. Okay, I will only allow students who have complete submissions to attend both. Okay, so in the future, pag hindi kayo nakapag-submit on time, of course, not only do you have sanctions or deductions sa points, but also, pag hindi kayo umabot or pag wala kayong submission by the time the class starts, hindi ko kayo papayagang umattend. Okay? Ng class. Kasi essentially, yung dinidiscuss natin sa post-lab ay yung answers dun sa questions. Okay? However, naka-record naman ito. I-record ko ba? Yes. Okay, naka-record naman ito. So this will be, the video will be made available to you as soon as you are, anong tawag dito? As soon as you submit or you make a complete submission. Okay, now also a reminder, for group submissions, both must submit or must click the submit button sa sarili niyong VLE. Okay, and the reason for this is that kasi submission ito, nag-agree kayo, okay, dun sa submission na gagawin ninyo. Okay, so kung ano man yung contents na yon, nakita niyo ninyong pareho and you kino-confirm nyo na yun yung gusto niyo i-submit. Okay? So both of you has to or have to click the submit button. Okay? Okay, now, based on dun sa mga na-checkan ko na, submit your answers with sound basis and proof. Okay, tulad nung piniliwanag ko kanina or kung paano ko in-explain yung discrepancies, ganun din dapat kayo magsasagot. Hindi pwedeng hypothesis lang. It will no longer work. Okay, sinasabi ko sa inyo, just stating the hypothesis without doing anything else, okay, para i-prove yung hypothesis ninyo, that's, anong tawag dito? That will no longer suffice. Okay, so kailangan yung i-follow up yung hypothesis ninyo as much as you can. Okay? Nakita ko rin na yung iba sa inyo, okay, nagpe-present ng graph. Okay? Ang ginagawa ninyo is isa-isa ninyong pina-present yung graph, so one by one. And well, actually wala pa akong nakita na nag-present ng multiple graphs. Okay, now I just want to ask you a quick question. Okay? How is this graph para sa inyo kumpara dun sa graph na sinasubmit ninyo? Kasi dun sa graph na sinasubmit ninyo, iniisa-isa nyo yan. And kung iisa-isahin nyo yan, how can you compare kung ano yung nangyayari individually? Okay? Halimbawa, itong black, at saka itong red, at saka yung blue, tatlong separate graphs yan. Paano nyo mako-compare yan kung hindi nyo sila superimpose sa isa't isa? Right? Okay? So, you have to present your results in such a way na both you or kung may partner ka, your partner, at saka pati ako, ay maintindihan ka agad kung ano yung results. When you make a presentation of your results, okay, that presentation must stand alone. Okay, ibig ko sabihin, without any text, kung titignan niyo itong graph na to, without any text, okay, alam niyo na kaagad na mayroong differences between the input voltage, output voltage from the bridge rectifier without the capacitor, and with the capacitor. Pero kung se-separate niyo sa 3 or 4 na graph, paano niyo makikita yung differences? Right? Okay? So you have to really make an effort to make a presentable graph. Sinabi ko naman yun dun sa instructions. Okay? Secondly, hindi kayo naglalagay ng labels. Okay? Amplitude, period. Itigil niyo na yung practice ng tawag dito. Kontento na kayo na ganyan lang. Okay? If you're going to do something, do it correctly. Okay? So, anong tawag dito? Yan. Kitang-kita nyo na yung x-axis ay yung period, yung unit ay second, yung y-axis ay amplitude, okay? Unit ay volt. Okay? So, klarong-klaro kaagad kung anong ginagawa ng figure. I don't have to do anything else. Okay? Just look at the figure, alam ko na kaagad kung ano yung nakikita ko. But if I look at your report, hindi ko naintindihan kung ano nangyayari. Unang-una kasi, yung isang nag-submit ng report, isang grupo na nag-submit ng report, ang labo nitong numbers. Kinuha ninyo yung lowest resolution para i-submit sa akin. So hindi ko nakikita ngayon, hindi ko ma-verify ngayon kung ano kung yung kiniklaim niyo is correct or not. Okay? So how can you imagine submitting that kind of anong tawag dito? Of result? How can I verify yung sinasabi ninyo dun sa text with the figure that you're submitting? Di ba? Sa figure ninyo, ang labo ng text ninyo. Hindi ko malaman kung ano yung value, kung ano yung magnitude. Okay? Anong tawag dito? Wala pa kayong x-axis scale. So anong malay ko? Di ba? Of course, I have to, it's easy for me to deduce. But, I mean, let's talk about, for example, pag nagtitesis na kayo at ganun ang ipepresent ninyo, at makikita yan ng tawag dito advisor or nung examiner ninyo. Okay? Anong sasabihin nila? Una nilang sasabihin, ano yung graph na yan? Yun ang una nilang tatanong. Di nag-aksaya pa kayo ng oras sa thesis defense ninyo just explaining the graph. Right? When you could have made the graph presentable already and you can have made the graph stand alone, okay? And then diretso na kayo sa gusto niyong pag-usapan, which is yung results niyo talaga. Okay? It's not good practice. Hindi yan magandang practice. I mean, it's probably a practice that you've been doing before kasi yan yung nakagawian. Pero I mean, at some point you have to do what is really right. Diba? Okay. You're making a submission. You're trying to convince your teacher, okay, or somebody else. Okay, pag nagre-research kayo, ganun na rin naman eh. Pag scientist na kayo later, ganun din. Meron kayong graph and you're convincing another person na what you're doing is tawag dito, worth doing. It's correct. Diba? And tawag dito, this kind of practice that you're doing now is not the way to do it. It's not the way scientists present or results to each other. Okay? So ayusin yung ano niyo, ayusin yung presentation niyo. Okay? That's why I'm giving you 2 weeks for this. Of course, there's another reason dahil bagal nga yung tawag dito, yung file, yung MATLAB. Okay? But you know, 4th year na kayo next year, tas ganyan pa yung ano niyo. Okay? So I leave this next slide sa inyo. So this is since Holy Week naman, di ba? Maybe this is something for you to reflect on. Okay, so what you're doing hindi lang sa klase na to but in any class. Okay? It's not about what your teacher or your advisor or kung sino man, it's not about what they want. Okay? It's about you, okay, attempting to achieve excellence for the first time. So if you're going to do something, you do it right the first time. Okay? Okay, so I hope I got my message through. And of course, hindi ko na to ulitin sa next na meeting natin. And anong tawag dito? We'll just stick to the discussion. But I hope hindi ko na rin ulitin to dun sa future na kung magiging estudyante ko pa kayo sa future na classes, hindi ko na rin ulitin ito. Kasi I think you're old enough to understand all these things. Okay? Okay, so any other things you want to say or questions you want to ask? Comments? Okay, so kung wala na, then I'm going to thank you again for coming, and I hope meron kayong napulot from this discussion, especially on how to do your succeeding, how to analyze your succeeding, the results from your succeeding experiments. Okay, so if there's nothing else, then I'll see you 3 weeks, 3 weeks from now. Okay. Have a holy week. Yun na lang yung masasabi ko.